So I wanted to make a few extra videos of a few types of problems that I plan to put on the exam here. And so here are just a few of these. It's a variety of problem that you might not have seen before, and I wanted to sort of give you some experience. It's not really difficult, but it's the kind of thing where you need to know what you're doing and just sort of keep your wits about you. I wanted to show you a few examples of those in the various settings we have. So the first example is this. Given the vector b is negative I plus bj plus 3k, and vector w, let's suppose that's given to be 4i plus 2j, and so we're in three-dimensional space, so we don't have a value for k. And suppose that we know that v and w are orthogonal. So we're given that those two vectors are orthogonal. The question we have is, what must the value be? So what must be this component of the j vector in vector v if we're requiring that these two vectors must be orthogonal? And so the problem is straightforward. What we're asked to find is b. So there we are. So we need to find v, and the requirement is that the vectors must be orthogonal. Recall that two vectors are orthogonal if and only if their dot product, two non-zero vectors are orthogonal if and only if their dot product is equal to 0. So if we form the dot product of these two vectors and set that to 0, that should allow us to back solve for the value of b that we're looking for. So we require that v dot w, so we must have v dot w equal to 0, which is to say that the dot product of these two vectors, which means first component times first component, second component times second component, third component times third component. Remember, if there is a missing k vector here, then this is the same thing as plus 0k, and I'll just put that there just for emphasis. And so if we form the dot product, that requires that negative 1 times 4 plus don't know yet times 2 plus, turns out it doesn't matter, times 0. That dot product has to equal 0, and that's going to allow us to back solve for b, because what that implies is that negative 4 plus 2b, that drops out, is equal to 0, and it's not very hard to see that this requires b to equal 2. So solve that equation, b equals 2. So it's straightforward, but you need to know what the terminology means, how to obtain that terminology, and then the actual solving is straightforward and not particularly difficult. So that's the first example, and we'll have a few more examples on the next upcoming videos.